Thank you for coming out. Great to see almost full room here today, and hopefully you didn't have too much travel issues trying to get in front of the storm. But if you don't know who I am, I'm Nick Kuhn. I do tech marketing at VMware, and I specifically focus on Cloud Foundry and the Tanzu Application Service. And today I'm going to be talking about why you don't need Kubernetes to be cloud native. Now, just to kind of get a show of hands here, does anyone consider themselves to be an application developer? Anybody platform engineer or system admin, IT architect? All right, are you looking to try to help your developers be more productive? Yes? Okay, all right. So if we continue on here, just this is our standard disclaimer. You've all probably seen it a lot now, but in case I cover any future-facing items, that's always subject to change. Just a brief agenda today. I'm going to go over what is cloud native. I'm going to cover why you don't need Kubernetes to be cloud native. I'm going to go into an intro to the VMware Tanzu Application Service, go into demo, and hopefully a little time at the end for questions, or we can move that out to the hall as well if needed. So if we look at what cloud native is. So this is just a generic definition from actually Tanzu's own website of cloud native is an approach to developing, deploying, and running applications using cloud computing methods and tools. If you Google this, most results will give you that first paragraph in a similar format, but you start scrolling down, they'll start referencing Kubernetes, and then that's okay, because there's this thing called the Cloud Native Computing Foundation, which is the open source ecosystem around Kubernetes and all the different various projects and things around that. But I'm going to cover why or how you can do that without Kubernetes to be cloud native too. So if we go back to 2011, we have this concept of the 12-factor app that was introduced. It was introduced by an engineer from Heroku. And if you don't know what Heroku is, it's a platform as a service. But this actually, it's about predating Kubernetes, 3-ish, maybe 4-ish years. And it's really talking about characteristics, patterns of applications that make an application scalable and portable on cloud ecosystems or cloud platforms, right? And like the biggest, first barrier of entry is just making sure an application can run more than one copy of itself, concurrency. Obviously, that's very important if you want to do things like elastic scaling up and down, running multiple application instances at one time. Also, backing services, taking state out of the application, whether that be a database, some kind of file, message broker, things of that nature. So decoupling state and out of the application, and then that kind of led into this concept that we call stateless web applications, and maybe potentially called microservices. And this is all kind of leading up to if you look at Netflix or Amazon or these big .com presences, they are all running microservices at scale, and you might even see them referred to as Death Stars, and where they have this big mesh of services kind of talking to each other. Now if we go back, or actually we stay in year 2011, we have another great invention, Cloud Foundry. Again, also predating Kubernetes. If you don't know what Cloud Foundry is, I'm going to talk about it a lot today. But it is an open source ecosystem that is a platform as a service that's designed and built to run cloud native workloads. And really, a lot of the talk too will be focusing on what abstraction level should you be at? What do you want your developers focusing on? And you may have seen this slide before in some various format, but you really, whether it's pizza as a service or just generic columns of IaaS, CaaS, PaaS, or FaaS, I'm going to be focusing a lot of the platform as a service layer. We'll be talking a little bit about containers as a service too, but I think we talk about this. I think we're continuing to see that the sweet spot is at the PaaS layer, where it's enough functionality for the developers and enough flexibility for the organizations to go through. Now, being in the Cloud Foundry ecosystem for over a decade now, we have some perspectives that we've seen over the past few years, especially as we watched Kubernetes become a thing and grow into this mega kind of status. But for those of us who've been in this industry for a while, we've kind of noticed a few trends. So if we fast forward to 2017, right, Kubernetes was released sometime in 2014. You've probably seen a notion of Kelsey Hightower. He's kind of one of the lead advocate for Kubernetes. And he states here, and Kubernetes is a platform for building platforms. It's a better place to start, but not the end game. And that, to me, kind of illustrates this is the time that the Kubernetes ecosystem was starting to realize that just handing developers Kubernetes and expecting them to be super productive was not necessarily the best approach. And if we fast forward to 2022, we have a thread started by Sid, and this is, I couldn't show this all because it's like a mega thread on Twitter or whatever we're supposed to call it now these days. But we start with fact one. Most developers don't like dealing with infrastructure. They want to write code and run it somewhere, but don't care much where that is. So we're starting to continue to focus on this abstraction layer where we don't necessarily want our developers dealing with lots of infrastructure. We fast forward to just a few weeks ago. We've got Kelsey here again, talking about transitioning different APIs, infrastructure APIs to workload APIs, but I've highlighted a very interesting concept here, here is my app, run it for me. Not give me a database, VM storage, and load balancer so I can run it myself. So this is 2023, just a few weeks ago. We're still kind of talking about, in the Kubernetes ecosystem, these developer abstractions and what level to offer them at. So being in the Cloud Foundry community, I obviously have some opinions on that, but that's okay if, at VMware Tanzu, we have a lot of Kubernetes offerings and we have a lot of solutions for that too, but I'm really here to show you a potential alternative path. Now, if we go back in time, let's say 7 to 8 years earlier, we see the CF push haiku being introduced. I don't know if this was the first instance of this haiku, but this is one from one of the famous videos with Ansi in it, but it reads, here's my source code, run it on the cloud for me, I don't care how. Well, that seems like a very familiar trend with our previous tweets from the past and future. So again, we really want to focus on this the developer abstraction, making it easier for developers to be productive. Now, I'm going to go into the Tanzu Application Service and give you a brief introduction. So if you're not familiar with it already, Tanzu Application Service is a distribution of Cloud Foundry, because Cloud Foundry is this open source ecosystem. So this is VMware's distribution of Cloud Foundry. It's very scalable by default, multi-cloud by default. We use something called BOSH, which is kind of this infrastructure superpower automation engine. So we can essentially deploy this on any VMware-based environment. The main hyperscalers, we don't have OpenStack listed there, but we still have that too. So essentially, BOSH will deploy the platform on your infrastructure service as needed, or multiple cloud infrastructure services if you want to go that route as well. And it's got all these great things too, where it's got a concept called build packs, where it's going to scan that source code that a developer provides and kind of build a container for them and manage it for them. Things like backing data services, where we can extend the platform to offer database as a service, Rabbit as a service, to help hit some of those 12-factor principles. We're at Spring 1 today, so it's a great place to run your Spring applications. In fact, you actually get extended commercial support if you run Spring applications on Tanzu Application Service for free. So if you're interested in getting ahead of the end-of-life date for Spring Boot 2.7, which is in November-ish this year, you might want to take a look at this. This could help you out. And additionally, we see a lot of value from our customers with the platform. So we continue to see this massive scale of operational or engineering efficiency with the platform. I've got a whole section on that later we can talk about. We have this concept of this developer ease, developer experience. CF push really drives developers using the platform to be more productive. We have this whole service lifecycle built around backing services to really make that easy to consume and govern. The platform's zero trust by default. We have we don't allow you to route SSH into containers that are deployed. Developers are abstracted away from VMs. They don't have to deal with SSHing into the boxes or anything like that. There's container networking that's zero trust by default to help the microservice communication to be more secure. And we have this whole concept of rotate, repair, and repave, where utilizing BOSH, we can rebuild the platform without taking downtime. And some of our customers actually do this every week just to get to a golden, clean security image. Maybe that's every month or every quarter. But that equates to thousands or tens of thousands of VMs just being rebuilt on the fly. And now if we look at where Tanzu Application Service is in the market today, so 24 of the Fortune 100 are running Tanzu Application Service to run mission-critical applications, highly secure applications. 5 of the top 20 financial institutions run mission-critical retail banking-style applications on it. 4 of the top 20 retailers run e-commerce, and a whole suite of different kind of applications from that perspective as well. And furthermore, from an investment perspective, we see a large investment from VMware itself in the Cloud Foundry ecosystem and our customers. So we have about 12 plus years of running production applications in production with Cloud Foundry. We have many app instances currently running. If we look at from a global landscape, that is the tune of millions of application instances or containers, if you don't know what that is, across the Tanzu Application Service customer base and the open source Cloud Foundry ecosystem. We continue to see growth with our enterprise customers, where they will grow about 30% year over year, and they're continuing to vote with their wallets by renewing 3-year contracts and continuing to invest in this platform with us. And of those millions of containers running in production, we have at least that we know of about 800,000 of those are running directly on public cloud infrastructure providers. So not just on vSphere. So we have a big multi-cloud, true multi-cloud presence with that. Now let's talk about some of the developer experiences that you see with Tanzu Application Service. So I'm going to go back to this haiku of here's my source code, run it in the cloud for me, I don't care how. And that really grounds a lot of this platform with this experience. And if we look into the overall developer experience, that CF push, what does that look like in reality? You're going to upload your code. With that command, it's going to scan, the platform will scan the code and automatically detect what language it's using and then apply the appropriate build pack to make a best practice container. You're going to set up routing, load balancing, encryption. That's all going to be handled for you. You'll have this health monitoring and logging subsystems wired up. It will make sure your app is healthy. It will scale it up to the number of instances needed. We have a great thing called Application Autoscaler that can scale it up and down based on demand, and you can have a lot of different parameters that you want to apply to it. And we have this concept of backing services that kind of grows or kind of transitions into this Tanzu Application Service or Cloud Foundry marketplace, where you can platform engineer or IT administration or whatever you want to call yourself these days, you can add additional services to your developers. So if you want to offer MySQL as a service, Redis as a service, Rabbit, Gemfire, or you want to actually extend this to these cloud hyperscalers. We can add something we call the cloud service broker and then allow developers to provision like an AWS S3 bucket or a Google Cloud Spanner instance, things of that nature. And that looks like, from the flow of, you have a developer who already has an application, they can just easily say with a CLI or a few clicks within a UI, say, I'd like a MySQL database. And then the marketplace, the service broker will go ahead and create that and wire it up to their application on the fly. So that being said, let's actually see some of this in action here. And we'll see how good the conference Wi-Fi is. So we'll flip over, maybe. Maybe we need to break out of presentation mode. Thinking about it here. All right. Okay, perfect. All right, how's that looking? Hopefully this is legible, this resolution, but I'm in a VS Code terminal. So I have an application called Spring Music. It's a Spring Boot application. I have a manifest YAML, which is a small file that's stored within my application code that kind of tells a few things about the platform, like what to name the application, how much memory to assign to it, where the path of the actual compiled code is, that the jar file. But let's go ahead and kick off a CF push here. So now this is taking the code, that jar file that's been compiled, and it's going to start uploading that to the platform, and it will start scanning it, and we'll see, we'll start to see what we call like the build pack process come up. We'll start to scan and detect what language it is. And hopefully this isn't too long here, but it seems like, yeah, so we can see now we're starting to download different build packs. It should see that it's a Java application, and we'll see a little line here that says Java build pack detected, perhaps. And then I'm going to flip over to the UI once we see that. Let's see here. There we go, Java build pack. It's starting to apply the best practices for that container. While that cooks a little bit more, I got a few things we can cover. So if we go to what we call Apps Manager, this is the main, it's a little blurry to you? Well, hopefully it's not too bad, but this is the main interface for, like the graphical user interface for Tanzu Application Service. You'll notice here that I'm in the admin view, and we see this thing called orgs. And I'm going to click into the Spring One organization. And then we also have these things called spaces. Now, this is something that we don't talk about a whole lot, but it's a super powerful construct of the platform, is that we have hard multi-tenant hierarchy, or within this product. So we have organizations which are commonly mapped to line of businesses within deployment, and then spaces are usually teams of that line of business. So we're abstracting with the infrastructure at a layer that it makes more logical sense, and then that really allows these deployments to be truly multi-tenant, and you have this concept where you can have thousands of developers, thousands of teams working on this system without competing or having issues with an infrastructure layer, because it's abstracted away. Right? They're not getting options in the Kubernetes landscape to like configure services or ingress controllers or things of that nature. They don't have to worry about any of that. Now, if we go into the demo application or demo space here, you can see that I just pushed this Spring Music Explorer app, and we'll launch it here. And we are seeing some CPU metrics come in, and just overall application metrics. If I scroll down here, we can see that I have one application instance running. You'll notice that there's like a little nice fancy Spring Boot icon here. That's another kind of benefit of running Spring applications on the platform. We have some additional telemetry that we can get on the fly, like if you wanted to like pull a live heap dump from an application, I think that's pretty useful. So we'll go back to our application here. Now, let's go actually see this application I just deployed. So if I click on route and open it up, load it here, survey says. All right, so again, it looks a little blurry to me, so I apologize about that, but this is a Spring Music application. You may have seen this before in the past, but it's a classic Cloud Foundry example application, and it just loads a default set of albums from a JSON file in the code. Now, if we go ahead and go back to our application, you notice we were running one instance. So let's just go ahead and say we need to scale this app up. We can scale to 3. So this is where we're kind of getting to the first set of these 12 factors of let's run more than one copy of the application at one time. We're starting. It's great and wonderful. No problem. But now, let's go ahead and add an album. And will I be gone? So I'm adding an album to the application here. And let's see. Oh, I don't think it actually saved here. But the fact is, I kind of did this demo a little bit out of order here, but it got saved to one of the application instances in memory. But now that I'm running 3, it's not going to show up until I hit that one application instance. So we can go ahead and fix that. If we go into the marketplace, we can see I have different services that I can extend with my application, whether that be Rabbit, Gemfire, MySQL, autoscaler or user-provided service. This list could be super long depending on how much, as a platform engineer, you want to offer for your developers. We just have a few loaded on this foundation right now. I'm going to go ahead and click the MySQL database instance service, and you can offer different plans as well. So again, I just have like very small plans here because this is a demo environment, but there are multiple plans you can select. You can do like the full HA, clustered MySQL across multiple nodes and things of that nature, but we're just doing the small plan here. And I'm just going to call this Explore DB01. And then I'm going to add it to the demo space, and I'm not going to bind it to an application. So go ahead and click Create. So now that's going to tell Bosch to go make a virtual machine and then make it a MySQL instance and then kind of wire it up to the space. But while that cooks, let's go back here. Go to the demo. String Music Explorer. So we have our application here. Let's go. I've already pre-built a database because that creation maybe takes 5 or 10 minutes depending on the speed of the infrastructure layer. So let's go ahead and just bind a service that's already there. So Spring Music Explorer, we're going to select that one. So when we do this binding, it's now talking to the application. It's going to wire up like the environment variables and things of that nature. Talk to the MySQL database, like the connection strings, the username, the passwords, and things of that nature. I'm going to go ahead and restart it so it can pick up those changes. But hopefully, once this restarts, you should be able to. We'll see the album set change, right? That means that the application is now reading from its persistent, resource, the MySQL database. And we can go from there. All right, so it should be restarted here. Let's go back to the demo. Let's see. All right, yeah, so 0 minute uptime. They just all restarted. So here's what we had before. Click refresh. All right, and now we have a new album set because we're actually reading from the MySQL database instead of the in-memory app database that kind of comes out of the box. You can see that we have the maybe you can see that there's in the top right hand there's a profile that says MySQL, and we're reading that Spring Music Explorer database we just created. So up until recently, this was like the primary developer experience of the platform. But in TAS 4.0, we actually added a whole new thing called this TAS Developer Portal. So we're going to go over here now. So, and if you're not familiar with the TAS Developer Portal, we have a new portal that we've been built. It's actually using a lot of the stuff we've been doing in the Kubernetes ecosystem around Tanzu Application Platform, which we're all tying into the open source project called Backstage, which was originally created by Spotify. So we're taking Backstage and kind of wrapping that out to be like a more enterprise level supported product. But we're using this to then span this as a common developer experience across all of our platforms, and really just to help everyone out here. But the first main functionality of this portal is what we call a catalog, or a software catalog. And that's essentially allows developers to register their services, like let's say an authentication service or a certain specific service to the organization that they can publish to within the developer community and allow them to use that service that's already there and not having to rewrite the authentication layer 100 times or whatever, things of that nature. So that's the whole concept behind the catalog. I can go ahead and kind of show you what will look like. So don't try to read that. I have a GitHub page where I'm storing a pre-built kind of catalog entry here. We'll go ahead and hit register entry. I'm going to import it now into the catalog. So it's going to scan that page, and it's going to import multiple different components and entries. So like that component, Spring Music Home Lab 2, that's an actual application. We have domains, we have groups and things of that nature. So this is all just like modeled organizational things to import into the system. And it should be imported now. So if we go back to the catalog, we can see that we have Spring Music Home Lab 2 in our catalog. If we click into that, we can see here, this is you can have a place to do like documentation, things of that for the application. And you have, we're starting to see this whole relational mapping between the application and what group it's a part of or what system it's a part of. And this is all like very flexible, like based on like kind of backstage. You can kind of model this however and whatever makes sense for your organization. Another feature of this catalog is the TAS runtime resources, where we're starting to pull into Apps Manager and see some things that are running on the platform. So if we load that here, we can drill down into a few things. Let's go actually into the app view. But we can see that I actually pushed this app about 2 months ago. And this is, again, some of the stuff that you would potentially see in Apps Manager, but we're trying to get this in this common developer portal. We can see a clear mapping of this ownership layer and different, how much memory, CPU you're using, that type of thing. How many application instances, routes, even some logs as well. So there's one more feature to call out too with the Tanzu Application Service portal. If we go into here, that's this concept of accelerators. So if you're not familiar with an application accelerator, that's really kind of we're trying to build this model to build best practice templates for organizations to offer to their developers. Say if you have a new developer onboarding or if there's a new project that's getting kicked off, you can have this kind of curated set of templates within the application accelerator view and easily offer that to your developers. And since we're at Spring 1 here, I'm going to click on the Spring Cloud serverless pattern or accelerator, and we'll go to click Choose. And that's going to give me that default name, and it's going to give me a deployment type of TAS. So if I actually drill down there, we can select different types of workloads we want to use, but we're talking about TAS, we can select that, and I'm going to go ahead and explore the file instead of downloading it here. But this is essentially a kind of a sample view of what it would look like, where you get the boilerplate source code for the whole project. You get like a README file, and that will go down into here to show you how you would, you'd run a Maven clean package to build a jar, and then you can run that cf push command to actually push that up to Tanzu Application Service deployment. You'll get a manifest YAML file to help you deploy it, and obviously if you drill down into that, you can actually start to see some actual Java code. But that's just an example of how we're thinking that these developer portals will be super helpful for organizations to manage the software catalog and view some overall runtime resources and really offer this concept of accelerators to kickstart development. Now, just as a note there, that with the TAS 4.0 release, that was a beta release of the Tanzu Application Service portal. So this is these features are still in beta, and we're trying to work on, we'd like to get feedback and see how we can improve the process. And there may or may not be an announcement coming out tomorrow about Tanzu Application Service 5.0 and what's in it. So keep an eye out for that too. But we're continuing to make progress with the developer portal. All right. So hopefully back to the slides. We can. All right. So we've done the demo. Now let's talk about some of the platform engineering views and outcomes with Tanzu Application Service. So let's go. Another haiku. Anzi was really great with these haikus back in the day, but it says, reads, here are my servers, go make them a Cloud Foundry, I do not care how. And that's referencing Bosch deploy. I don't think this one gets referenced as much as it should, but let's talk about Bosch, right? Bosch is this multi-cloud powerhouse infrastructure as code engine. Think of like a Terraform, Ansible, and some other thing kind of bundled together. That's all still open source, by the way, that will build and deploy things and manage them and maintain them and upgrade them. So it's great at day zero operations where it can talk to these infrastructure service providers, deploy VMs, databases, load balancers, whatever you need, and then kind of build a platform or build a database as a service or messaging as a service technology for you and manage that for you. But what really shines about Bosch is that from day 1 through 999 or day 2000, it's watching, it's monitoring, it's looking at what it's deployed. It will upgrade what it's deployed without completely destroying it. Let's say if we take a look at this example here, if we talk about the application runtime, which is called Diego, which is a container scheduler that predates Kubernetes. That's the core, one of the core technologies of Cloud Foundry. So if Bosch detects that Diego cell 1 is down or having a bad time, it's going to go ahead and say, hey, cell 1's dead. I'm going to delete it, send it to the cloud recycling bin, and we'll build a new VM, and we'll turn it into Diego cell 1 again, and it'll go green, and we'll add it back into the pool. Now, there are multiple different services and VM types behind Tanzu Application Service in Cloud Foundry, but it does that whole process throughout that. And it's kind of a similar model of we do a canary-style deployment when we do upgrades. So it will take one or two of the VM types and upgrade them and do some tests and things and continue that upgrade path. And that allows us to do kind of zero downtime upgrades during the day and things of that nature. And just a quick kind of recap of the overall architecture for Tanzu Application Service. So we have this Bosch layer that provides VM automation on our cloud providers. Diego, which is a lot kind of like Kubernetes, will run applications and schedule containers for you. Build packs will build and manage build and manage containers on the developer's behalf. We have a whole app routing tier, that was just handled by what we call the Go router. That's very akin to like an ingress controller in the Kubernetes landscape, where it's mapping, what container is running on what Diego cell and doing that whole translation there. We have a CLI and Apps Manager interface and Tanzu Application Service portal interface too to interact with the platform. And of course, we have this marketplace that's very extensible that we can, as organizations choose, they can choose to expand that and go well beyond just an application runtime. Now, the question is, so we're going to get into kind of platform engineering efficiency, but we started asking this question, how efficient is your platform? But really, we started asking the Tanzu Application Service customer base about this concept that we're calling platform engineering efficiency. So we asked our customers, how many platform engineers or how many people do you have running your platform? And then how many developers does that support? So on average, we'll see an average developer to platform engineer ratio. So one platform engineer will support around 190 developers. If we scale that out, the average team size is really about 6 platform engineers supporting roughly 1,200 developers. But we've seen some extreme cases where that ratio goes well plus 500 plus. So we'll have platform engineers supporting 500 plus developers. I actually used to work at a place where that was the case. So this is a very powerful platform in terms of efficiency. And if you want to learn more about this, I actually wrote an article in the New Stack kind of around the time of Cloud Foundry Day 2023 in June. But this was kind of to help celebrate the Cloud Foundry community and talk about how we've been doing this thing called platform engineering for over a decade now. You can scan the QR code, you can Google it, there's a link below. I'll try to post these like on Twitter and LinkedIn after the fact. I may or may not have more QR codes to scan after this slide, so I don't want to burden you too much. But another thing too to call out, I mentioned earlier, do you need some more time to help upgrade your Spring applications? Well, again, I wrote a blog. There's a QR code to scan. There's a whole blog kind of documenting that, but just to say that, hey, Spring and Spring Boot applications run great on this platform. You get commercial extended support out of the box with your license. And you also get access to some of these Spring advocates that, like Dan Vega was here just beforehand, these great Spring developers, advocates, the folks that are writing all this code, you can get direct access to them as well. So that's great to call out. And then another thing too, so we talked a lot about MySQL. Well, there's this impending migration too from MySQL 5.7 to MySQL 8.0. And again, I apologize, one more QR code. But we also offer extended MySQL support as well through our tile. So if you need some more time to upgrade, make that database version upgrade, we have that as well. So I think we're going to go to questions now if we have some time. I do want to call out one thing here, if I can get back to my other view. All right, we're kind of flashing here, but I'll bring up too. There's a session later today. If you want to learn more, this is going to kind of be a little bit of this session plus more. There's a 90-minute tutorial where we're gonna really model a full kind of loyalty retail application with Tanzu Application Service and multiple data services together. We're doing a hackathon later tonight where we're starting to integrate GPU support and things of that with the platform. So that's going to be, I think, pretty interesting too. So let me see if I can get over to my web browser here. So yeah, in a few minutes, if you want to learn more, 1 p.m., you can come check us out to do more Tanzu Application Service. But there's a link here. I'll put this out I actually put it out a lot of times already on LinkedIn and Twitter if you want to look there. But just to get if you want to see all things Tanzu Application Service at Explore. But I think with that now, if we have any questions or, I can leave time for questions now. Can you potentially walk up to the, mic so we can record it?
I only have one question. On one of the slides, I think it was maybe 8 slides back, when you showed the actual breakdown of what Tanzu actually does as a replacement for Kubernetes, one of the apps had a 1 next to it. And basically, while I was locked there, we had a 1, but down at the bottom it had several different versions. And so basically, if something was corrupted on one of those versions, I saw the same version come up again. So basically, my question is, does it fix that particular version, or does it revert back to an earlier version?
Are you talking about like an upgrade, or I'm sorry, I don't quite understand the question.
Basically, when an application, let's say one particular, let's say microservice, is broken, right? Usually it'll default. It'll basically try and get rid of that one particular service, right? So basically I assumed there was different services, and I may be wrong, but okay. I saw 1, 2, 3, and I saw that the one that had the number 1 was corrupted. It had a red box, right?
Right, okay.
And so he got rid of that microservice. And that same one, because I never used this platform, is it somehow revert back to
so I know which slide you're talking about now. So that's where I was talking about Bosch, and that was actually scheduling VMs and maintaining the VMs. So one thing that I guess grasp is that Bosch will deploy a bunch of virtual machines that make the platform, and like developers interact with like the APIs and CLIs, and they push their applications there. They don't really talk to the VMs per se. So like then the VMs run like that. I was referencing Diego, which is like the container scheduler. So think of that could be akin to like, I have a Kubernetes cluster and one of the Kubernetes workers died. So like Bosch would just recreate that. So that was the flow of kind of the platform engineering view of how, when we manage all these virtual machines that are running the platform, if we lose a VM, we can just rebuild it and on the fly and get it back in the pool. And how we do that from the application side is like, when you push an application, you'll usually, like the best practice is to run at minimum 2, right? So if there's that instance, if a VM goes down or something like that, the app will still be up, if that makes sense.
Yeah, it makes sense. It does the same with another platform I'm thinking about, Kubernetes. But yeah, that's all I wanted.
Okay.
So as long as it's self-healing, basically what you're saying too, yeah. It's self-healing. So.
All right.
Thank you, sir.
Thank you. Any other questions? All right. Well, thank you.